Welcome to your first interactive Arduino build. By the end of this video, you are going to wire a physical button that tells an LED to light up the exact moment you press it. To bridge the physical world with the digital one, we will move through three specific processes: wiring a breadboard, writing a software program to control the logic, and building a custom hardware switch to trigger the action. You need a few components to build this circuit: an Arduino Uno, a breadboard, a single red LED, a tactile push button, some jumper wires, a 220 ohm resistor, and a 10K ohm resistor. On the software side, you simply need a computer with the free Arduino IDE installed and open on your screen. Mastering these foundational hardware and software basics allows you to configure the Arduino as a computer that actively responds to physical signals from its environment. Let's build the power circuit. Start by taking a jumper wire and connecting the 5-volt pin on your Arduino directly to the red positive rail on your breadboard. Next, take a second wire and connect one of the Arduino's ground pins to the blue or black negative rail. The breadboard's internal metal strips connect these holes in long, continuous rows. By plugging into these specific rails, you now have 5 volts and a ground connection available anywhere along the length of the board. Now grab your red LED. If you look closely at the metal legs, you will see they aren't the same length. The longer leg is the anode, and the shorter leg is the cathode. This physical difference matters because electricity can only flow through an LED in one direction. Plug the LED into the center of your breadboard. Make sure the longer leg is oriented toward your incoming power source, and the shorter leg is positioned toward your ground line. Next, take your 220 ohm resistor. Plug one end into the same row as the LED's longer leg, and use a wire to connect the other end directly to digital pin 7 on the Arduino. This diagram shows exactly why we need that resistor. Without it, the LED would draw too much current from the 5-volt source and burn out immediately. The 220 ohm resistor acts as a bottleneck, reducing the flow of electricity to a safe level. With the physical loop complete, power can only reach the LED if pin 7 provides it. We have turned a physical connection into a programmable power gate. Let's look at the software that controls that gate. This image of the Arduino IDE shows the two main structural sections of every sketch: the setup block and the loop block. Inside the setup block, which runs exactly once when the board powers on, we declare our hardware intent. We type pin mode, open parentheses, 7, output, to tell the Arduino that pin 7 will be sending voltage out to the LED. Down in the loop block, we write the instructions. We use digital write 7 high to turn the LED on, delay 1000 to pause for 1 full second, digital write 7 low to turn it off, and another delay so we can see the change. Before you proceed, check your punctuation. The Arduino language requires a semicolon at the end of every operational command. If you miss one, the code will fail to compile. Click the Upload button. You will see the small lights on the Arduino board flicker rapidly as the data transfers, and then your physical red LED will start blinking, exactly as programmed. Observing that steady blink definitively proves your software and hardware are communicating correctly. With a stable output established, we can safely introduce our input logic. Before adding any new components, physically unplug the USB power cable from your computer. Never modify a live circuit. Take your tactile button and press it firmly into the breadboard so that it bridges across the central dividing gap. Now grab the 10K ohm component. We are going to use this as a pull-down resistor. This schematic illustrates the pull-down effect. When the button isn't being pressed, the circuit is open. The 10K ohm resistor connects the digital pin directly to ground, which forces a stable 0-volt reading to the Arduino. Physically pressing the button overrides that resistor. Closing the switch opens a path with 0 resistance, overpowering the ground line and instantly flooding the pin with 5 volts. To build this, connect the unresisted side of the button directly to your 5-volt power rail with a jumper wire. Plug the 10K ohm resistor into the opposite leg of the button and run it to ground. Then connect a wire from the exact junction point between the button and the resistor directly to digital pin 8 on the Arduino. Back in your software setup block, add a new line, pin mode 8, input. This tells the Arduino to actively listen for voltage on that pin. Successfully capturing a volatile physical action, like a button press, as a stable digital variable is the fundamental building block of interactive computing. This graphic shows an if-else statement. We use this structural logic as a conditional decision maker for the board, telling it how to react. Inside your loop, program the condition. If the digital read of pin 8 equals high, digitally write pin 7 high. Else, write pin 7 low. Reconnect your USB power cable and click Upload to send the completed sketch to the board. Now press the button. The system reacts instantly, with the LED responding perfectly in tandem with your physical interaction. This basic digital on and off foundation translates directly to your next steps, where you can use analog sensors like dials to measure a range of values or photoresistors to detect light. You have now translated a physical human action into digital logic and back out into a physical environmental change. This logic loop, input, processing, and output, provides the foundation for more advanced interactive electronics.